Hi, Math 30-1s. Just continuing on today with trigonometry functions and graphs. Today we're going to focus on trig ratios. So the beginning of this lesson will look very familiar to you from Math 10 and Math 20, the trig units you did there. And then once we get past the beginning, half page here, everything will be kind of new to you in terms of the ratios we're going to be discussing. But again, what we want to focus on here moving forward is that the ratios we're going to talk about today, whether they're primary or reciprocal ratios, are going to be applicable to right angle triangles. So remember, when I talk about a right angle triangle or a 90-degree triangle, okay, we know that we are dealing with one of those triangles because there is either in a diagram a little square in the corner there, or we know that the two sides that make that angle are perpendicular to each other, okay, and therefore a 90-degree angle is occurring. So taking a look at our primary trig ratios, which are the ratios we learned in grade 10 and 11, sine, cosine, and tangent. And again, a lot of you always remember, okay, your acronym that you were most likely taught, which was SOHCAHTOA. Okay, now again, SOHCAHTOA is not a mathematical term. It is an acronym that helps us remember the relationships of sides in a right angle triangle when we're calculating the sine, cosine, or tangent ratios. Okay, so when we say SOHCAHTOA, that is not a mathematical term. It is an acronym that helps us remember something, okay? So when I take a look at that acronym that most of us use, the S, the C, and the T, okay, obviously stand for sine, cosine, and tangent. The other two letters in each of the three little expressions there, O and H, stand for opposite over hypotenuse, okay? In the CAH, the A and H, that stands for the adjacent over the hypotenuse, and for tangent, the O and the A stand for opposite over adjacent. So again, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. When I take a look at the diagram that they have provided for me, those opposite, adjacent, and hypotenuse sides are basically applied to theta, the angle we are using. So we call that the reference angle, the angle I'm referring to in the diagram. So you can see here they've labeled that as theta. So in that case, the side directly across is the opposite, and the side right beside it is called the adjacent. The hypotenuse never moves. It is always the longest side in your triangle, and it is always directly across from the 90-degree angle. Now, if I move that theta, so let's just say for now, okay, and I'm going to color it out here so we don't see it. Let's say that that's not the angle I'm talking about, but I now move theta to the other acute angle in the triangle. So it's there. Well, now this side here would now be the opposite side. The side beside that reference angle would now be the adjacent side, okay? But like I mentioned earlier, the hypotenuse would not move. It would remain where it is, and again, it's still the longest side in the triangle. So when we talk about theta, or the reference angle that we're going to be discussing moving forward here, we have to be aware of where that reference angle is, because that determines which side of the right angle triangle will be the opposite and which side of the triangle will be the adjacent. Okay, so hopefully that little diagram makes sense to you. And then just below here, it does say that we use this acronym SOHCAHTOA to help us remember the relationships of the sides for our primary trig ratios. Okay, so again, just a review of what we've studied so far with trigonometry. Now let's move on to new material. So reciprocal trig ratios. So with reciprocal trig ratios, the three new ratios you're going to learn are cosecant, okay, which is going to be represented by CSC, secant, okay, which you'll see notated most times as SEC, and cotangent, okay, which is notated as COT. Those are just the short versions that the textbooks and a lot of material use to write them out instead of writing the whole expression out. Now, if you look at cosecant of theta is 1 over sine of theta. Secant of theta is going to be 1 over cos of theta, and cotangent is going to be 1 over tan of theta. So obviously each primary ratio has a reciprocal counterpart, okay? And this is the way it kind of works, and I'll just show you in a little diagram here on the side. So we have primary ratios, and we now have reciprocal ratios, Okay, so we have the two. Primary, we know we have sine, cosine, and tangent. Okay, and we just learned that our reciprocal ones are cosecant, secant, and cotangent. All right, so the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So how do I remember which primary ratio goes with the reciprocal ratio? Well, each pair only has the prefix co in it once, which is what they basically are stating down here. So when I say sine and cosecant, you only hear the co prefix once. When I say cosine and secant, you only hear the prefix co once. And when I say tangent and cotangent, you only hear the prefix co once. So when I say the primary and reciprocal counterparts, you should not hear the prefix co twice. So that's why you know cosine does not go with cosecant, because then you've heard that prefix co twice. So those are the wrong pairs, okay? Now, what are those ratios? Well, we know that sine, for example, okay, sine is opposite over hypotenuse, okay? So therefore, cosecant is going to be the hypotenuse over the opposite, okay? For cosine, cosine is the adjacent over the hypotenuse, okay? So therefore, secant would be the hypotenuse over the adjacent side. Okay, and then the last one, tangent. Tangent we know is opposite over adjacent. Okay, so therefore cotangent ends up being the adjacent side over the opposite. What we're going to focus more on though are the values of the primary and reciprocal ratios. So if I give you one example, you'll see how these work moving forward. So like I said, if I gave you, and we go up to sine, and I tell you the sine of a ratio is, say, 2 over 3, okay? When I go across to cosecant, it's going to be 1 over 2 over 3, okay? Which ends up being 3 over 2, okay? The numerator became the denominator, okay? And the denominator became the numerator. Now, we're going to run into some trouble moving forward where we have to do something called rationalizing the denominator, which you learned in Math 20, but you will see we'll deal with those issues when we get there. For right now, you need to know the reciprocal trig ratios are 1 over the primary trig ratios, okay? So that's what we've learned here. Now that we've talked about those ratios in terms of opposite, adjacent, and hypotenuse, what we're going to do is we're going to extend that into quadrants 1, 2, 3, 4 in a coordinate plane, just like we've been studying the last couple days, as we've been talking about reference angles, rotation angles, coterminal angles, those types of things. So you can see in the diagram here in class example 1, they've drawn a nice right angle triangle for us in quadrant 1, okay? And here is the 90-degree angle that's formed in the corner, okay? So what they've done is they've also labeled theta, or our reference angle in this question, which is right here, okay? Now, the side beside it, which is normally the adjacent side, is x. The side across from theta, which is the opposite, we now call y. And then we are now going to be calling the hypotenuse r, okay? So we're going to be using the variables x, y, and r. R moving forward will be the radius of something we're going to study called the unit circle. But for right now, r is the hypotenuse of this angle that we are studying in the diagram. So when I take a look at this triangle, and I'm going to start with sine of theta. Okay, so we know sine of theta is always the opposite over the adjacent. So if this is theta, there is the opposite, and there is the adjacent. So sine will be y over x. Opposite over, oops, nope, that is 100% wrong. I am so sorry. Sine is opposite over hypotenuse. So that is y over r, okay? For those of you that were confused at home, okay, you had a right to be, that was wrong, okay? When I move on to cosine, okay, cosine is always the adjacent over the hypotenuse. So it will be x over r. And tangent, okay, when I'm studying tangent, tangent is always the opposite over the adjacent. So tangent will be y over x. So when I go down to cosecant, remember cosecant is the reciprocal, okay, of sine. So cosecant would actually be 1 over y over r, which would make it r over y. Okay. Secant is the reciprocal of cosine, so it's going to end up being r over x. And cotangent, okay, is the reciprocal of tangent, so it's going to end up being x over y. Now at the bottom it says you should memorize these formulas. You can, okay, but I prefer, again, if we understand what sine, cosine, and tangent are. We've learned those for 2 years, and then we know that the cosecant, secant, and cotangent are calculated by going 1 over those values, okay? So they say at the bottom that some students use a phrase like 7 yellow rabbits. Okay, where does that come from? Well, S for sine, Y for yellow, R for rabbits. You can use any acronyms that you want. Again, those are really just tricks to help you remember something. They are not mathematical at all. So however you need to remember those relationships, I would say do that. Okay, we need them moving forward. All right, turn the page. So on the page, it says determining the sine of a trig ratio. So what they mean by the sine of a trig ratio is they're asking you, is the sine, cosine, tangent, secant, cosecant, or cotangent, is the value going to be positive or negative? Okay, and so this is where this comes from. And we'll start in quadrant 1 where they've started a calculation for me. So in quadrant 1, okay, when I talk about the reference angle, the angle that they are referencing or discussing, just like in diagram 1, this is the angle that they are talking about right there. Okay, the reference angle, remember, is between the terminal arm and the x-axis. So there's my theta. If I'm going to talk about sine, sine is y over r, right? We just learned that on the last page. Sine is the opposite over the hypotenuse, okay? So there's y over r. Well, the y value in quadrant 1 is positive, right? Because you're going up, so y is positive. R is always positive, so a positive divided by a positive, okay, yields a positive answer. We don't know what the value is, and we don't care at this point. We just know that the value is going to be positive. When I go and I talk about cosine, well, cosine, we're using the same reference angle. Cosine, though, is adjacent over hypotenuse, which is x over r. When I take a look at the diagram in quadrant 1, the x dimension of this triangle would be positive, divided by the radius, which is always positive, and that will give me a positive answer. Okay, when I move on to tangent, okay, well, same reference angle, tangent is opposite over adjacent, so it's going to be y over x. Both of those dimensions of that triangle are positive, so therefore a positive answer would result if I go a positive divided by a positive. So what did you learn about quadrant 1? All 3 primary trig ratios, sine, cosine, tangent, are positive in quadrant 1. Okay, so that's what we learned there. Moving on to quadrant 2. Now this is where it gets a little trickier, okay? In quadrant 2, if I take a look at the rotation angle in quadrant 2, so here would be the rotation angle from there to there. But as I mentioned at the beginning of the lesson, okay, so this is the angle theta that they're talking about. Sine, cosine, and tangent are applicable to right angle triangles. So what I do is, because that rotation angle I've just created, there's no way you're going to be able to create a right angle triangle from it, is I discuss what we call the reference angle, okay, which is this right angle triangle that is created in here, okay, that I've just basically discussed and drawn there. So I'm going to use that little dot as my reference angle here. That angle in there for that right angle triangle will give me the same values as the big rotation angle that I've drawn, but I can't talk about that big rotation angle because it's not a right angle triangle. So what I do with that triangle that I drew there, with the dot, which is the reference angle, is I label the bottom of that triangle x, the vertical dimension y, okay, and r again is the hypotenuse. And I'm getting to that point up there, which has a point of x comma y. Now we just go through our steps again. We know sine. Sine is always going to be y over r. When I take a look at that triangle I drew, the y dimension, the up and down, that's positive. Okay, that's still a positive dimension. The radius is always positive, so a positive divided by a positive gives me a positive result. Cosine is always x over r. Now this is where it gets different. in this diagram, the x dimension of this triangle would be negative because I would be going to the left to get to that point. So this would be a negative divided by r is positive, and a negative divided by a positive is a negative. Tangent, y over x. So that would be a positive divided by the x dimension is negative, so I get a negative. So what did we learn about quadrant 2? In quadrant 2, only sine is positive. The cosine and tangent ratios will yield negative solutions, or negative values is what I should have said, okay? So negative values for cosine and tangent in quadrant 2, a positive value for sine. Okay, we move into quadrant 3. So same kind of idea. In quadrant 3, here is the big rotation angle that has been created. Okay, there's the angle. I can't discuss that rotation angle in terms of sine, cosine, and tangent because it is not a right angle triangle that has been created. So what I do is I use the reference angle, which again is that little dot, okay, which will be in this corner here between the terminal arm and the x-axis. This time we'll color it in just because the rotation angle kind of covered it as part of it. So there's my reference angle. Here is the right angle triangle that is created, right, between the terminal arm and the x-axis. So again, that triangle that I've drawn has a y dimension and it has an x dimension. Okay, I have to go x units to the left, starting at the origin. You go x units to the left and then y units down to get to this point, x comma y. So again, we go through our steps. Sine is always y over r, which in this case, the y dimension is negative because you have to go down. R is always positive, so that gives me a negative value. Cosine is always x over r. The x dimension here is negative, r is positive, so cosine is also negative. Now tangent, the interesting one here, okay, is always y over x, which in this triangle I've drawn is a negative divided by a negative, which actually gives me a positive value. So in quadrant 3, only tangent has a positive value. Okay, going to quadrant 4, same kind of idea. Here is the big rotation angle. Okay, so there's theta. But again, I can't discuss that because it's not a right angle triangle, an acute angle. So there's my reference angle. Here is the right angle triangle that I create so I can discuss its properties. It has an x dimension. It has a y dimension. So we go through and say again, sine is calculated by going y over r. Y on that triangle is negative in quadrant 4. R is always positive. So sine is negative in quadrant 4. Cosine is always x over r. So that's going to be a positive over a positive, which is a positive. And tangent is always y over x, okay, which in this dimension will be a negative divided by a positive, which gives a negative. So only cosine, okay, yields positive results in quadrant 4. So the important note that follows is right here. Okay, it says the reciprocal ratios follow the same framework as their primary ratio, which means wherever sine is positive and negative, so is cosecant. Wherever cosine is positive and negative, so is secant. And wherever tangent is positive and negative, so is cotangent, all right? So when I take a look at that diagram, okay, the first question says, the sine ratios. So sine ratios are positive in 1 and 2. That's where sine gives us positive values. Cosine is going to be positive in 1 and 4. And tangent is positive in 1 and 3. So remember, everything is positive in 1. That's why 1 was the solution to the first 3 questions. Now, where is sine negative? Well, if it was positive in 1 and 2, it's going to be negative in 3 and 4. If cosine was positive in 1 and 4, it'll be negative in 2 and 3. And if tangent was positive in 1 and 3, it'll be negative in 2 and 4. Okay, so the easiest way to understand where the ratios are positive and negative is something that we learn called the CAST rule, okay, C-A-S-T. So the way it works is this, is C, cosine in quadrant 4, A, all ratios in quadrant 1, sine, positive in quadrant 2, and tangent positive in quadrant 3. So, you know, if you simplify it like this, instead of having all those words like they wrote, okay, it starts in quadrant 4, C, A, S, T. Okay, and again, this was quadrant 4, quadrant 1, quadrant 2, and quadrant 3. And again, those letters tell you which trig ratios are positive in those quadrants. So only cosine's positive in 4, all of them are positive in 1, sine is positive in 2, and tangent is positive in 3. Okay, determine without using technology. So again, when they say no technology, that just means do not use your graphing calculators. Determine whether the trig ratios are positive or negative. So really all we want to know here is which quadrant do we end up in, and therefore take a look at the ratio, sine, cosine, tangent, or the reciprocals, and determine if in that quadrant we are going to be positive or negative. And basically then all that they're referring to there is this cast rule. Okay, so that's what they're kind of asking you to figure out. Which quadrant do we land in? And based on what I've just drawn there, the CAST, okay, is my ratio going to be positive or negative in that quadrant? So first one is sine of 280. So 280 degrees, okay, that would take you into quadrant 4. So sine in quadrant 4 is going to be negative. That's it. You don't have to say anything else about it. They just wanted to know whether it's positive or negative. Okay. The next one, tangent of 7 pi over 6. Now again, 7 pi over 6 might be hard for us to understand, but remember from the other day that pi is like dealing with 180. So you could go pi times 7 divided by 6, or you could go pi over 6. So that's like 180. 180 divided by 6 is 30. 30 times 7 is 210. So that means you're going to be in quadrant 3. Okay, this is going to put you in quadrant 3. If I'm in quadrant 3 and I'm dealing with tangent, okay, you're going to get a positive value. Okay, you take a look at the diagram to the right there and you can see T is in quadrant 3. That's tangent. Okay, next one, cosine of 10 pi over 3. So again, if you're unsure of where 10 pi over 3 is in radians, kind of switch your brain to degrees. Pi 180 divided by 3. So 180 divided by 3 is what? 180 divided by 3 is 60 times 10. That's 600 degrees. Okay, so you take away the 360. Okay, and then you're going to actually end up in quadrant 3 here. So again, I'm in quadrant 3 and I'm dealing with cosine. Well, that's going to give me a negative value. All right. Now, in the next 3, you can see that we are dealing with the reciprocal ratios. But remember that for D, for example, we're dealing with cosecant. So cosecant, okay, is the same as dealing with sine. So I just worry about if sine is going to be positive or negative in whichever quadrant I'm going into. Now, the other tricky thing here in D is that the rotation is negative. So you're going in the clockwise direction. So you're going to go 225 degrees in the clockwise direction. That's going to take you into quadrant 2. Okay, so you're going to end up in quadrant 2 here because you go 225 degrees clockwise. So if I'm in quadrant 2 and I'm dealing with cosecant, which is like dealing with sine, that means that value is going to be positive. Okay? Sine is positive in quadrant 2, so therefore so is cosecant. Okay, the next one, again, a negative rotation, and we're dealing with 13 pi over 6. So again, what you could do if you're confused about radians is go pi over 6. So that's like 180 divided by 6, which is 30. And then 30 times 13, okay, is 390. So you're going to go 390 in the clockwise direction. That's going to put you in quadrant 4. So you're going to be in quadrant 4 with this rotation angle. And you're dealing with cotangent, which is like tangent. If you're in quadrant 4 with tangent or cotangent, your value is going to give a negative result. And then the last one here, 1,000 degrees. Okay, so obviously we talk about how many full rotations that will be. So if you went 1,000 divided by 360, you're having 2 full rotations. So that's 2 full rotations. So then 1,000 minus 720, which is 2 full rotations, that's an extra 280 degrees. That's going to put you in quadrant 4. Okay, so this is going to be quadrant 4 that you end up in. And we're dealing with secant. Okay, and secant is the same as cosine, or it is the partner to cosine. Okay, so if we're in quadrant 4 for cosine, that's going to give a positive value. Okay, so again, just trying to determine whether these values will be positive or negative, depending on the quadrant that their rotation angles end up in. All right, next, Degree mode or radian mode. So again, this goes back to what I mentioned the other day, which is on your calculator. If you push the mode button, which is beside second function, you'll see the third option down allows you to highlight either radian or degree, depending on the question. So if we read through the instructions here, it just says most calculators have the ability to calculate the values of sine, cosine, and tangent ratios in degrees and radians. To calculate the values of the reciprocal ratios, okay, we need to use the reciprocal of the primary ratios. There are no cosecant, secant, and cotangent buttons on your calculator. So what you have to do is, like I mentioned, understand how we get that calculation. So for example, if I'm talking about cosecant of 5 pi over 6, I would go 1 over whatever sine of pi over 6 is. So you would figure out what sine of 5 pi over 6 is, and then go 1 divided by that value, which will give you 2. Or the other way of doing that is, like I said, just simply find out what sine of 5 pi over 6 is, which is 1/2, and then go 1 over 1/2, which will also give you 2. Okay, so that's why they say or here. Okay, you think of it in one of two ways when you're calculating it, but that's how you get it. It's 1 over, okay, what the calculation is for sine. Okay, and that's why we call it the reciprocal, because that's what a reciprocal is. It's reciprocal means 1 over a value. So now, okay, the phrase we love to see, use a calculator to determine, and this time to 4 decimal places, where necessary. Okay, so again, that's important in instruction. So where necessary means if you have to. If you don't have to, then you don't need to. The value of the trig ratios for class example 2. So they want the sine of 280. Now, you'll notice for that one, there is a degree sign. That means your calculator should be in degree mode. So you go to mode, make sure that degree is highlighted, go second quit to get out of that window, and then simply go sine 280, enter, okay, and you will get a value that is equal to negative 0.98, and they wanted 4 decimal places, 48. Okay, so there's the first one. The second one, okay, is 7 pi over 6. So 7 pi over 6, that's an angle measurement in radians. So I have to go back to mode, turn my mode to radian mode, then you can go tangent of 7 pi over 6. So I'll usually go 7 pi divided by 6 and then go tangent of the answer. So that gives me, to 4 decimal places, again, a value of 0.5774. That's the value of the ratio. Okay. Next one again, the angle measure is in radians. So I can stay in radian mode because I'm already in that mode from the previous example. Go 10 pi, divide by 3, and then cosine of that answer, and you get negative 0.5. I do not have to put in 3 more zeros. If the instructions had said to 4 decimal places and that's it, they did not say where necessary, then I'd have to put in the 3 zeros. But they had said where necessary, so I don't have to continue on. Now the next one's interesting because as soon as we see sine 90, okay, we're accustomed to thinking, well, that's 90 degrees, but it is not. Okay, there's no degree symbol here, so this is radian, okay, or radians. Okay, so be very careful of that. So again, I'm not going to change my calculator mode. I'm just going to go sine 90 in radian mode, and this will give me 0.8940. Okay, if I round it to 4 decimal places. Okay, in E, okay, again, cosecant now, and degree mode. So what I'm going to do is I'm going to go, basically that calculation, what I would do is I would go 1 over whatever the sine of negative 225 degrees is. Okay, so first off, find what sine of negative 225 degrees is. Okay, so you're going to go to mode. Again, make sure you're in degree mode this time. Enter. Sine of negative 225, and then 1 over that answer, okay? And that gives you a value of 1.4142, okay? The next one, that's going to be radian mode, isn't it? Because this this measure is in radian mode, okay? So again, that calculation, because it is cotangent, is basically like saying 1 all over the tangent of negative 13 pi over 6, okay? So I would figure out the tangent of negative 13 pi over 6 first, okay? And again, make sure I'm in radian mode. So negative 13 pi divided by 6, the tangent of that answer, and then 1 divided by that value. Okay, so that's going to give you negative 1.7321. And then lastly, okay, degrees here, secant. So secant is the reciprocal of cosine, so this is going to be equivalent to 1 over the cosine of 1,000 degrees. So again, degree mode, then cos of 1,000 degrees, 1 divided by my answer, and this will yield a value of 5.7588. Okay, so that's how we use our calculator, and again, understanding if we're in degree mode or radian mode, and how to calculate those reciprocal values. Okay, next page. We're getting close to being done. Expressing trig ratios as an angle in terms of a reference angle. So what that means is that when we have angles that are larger than 90, okay, obtuse angles, okay, that go all the way up to, say, 360, full rotations and even larger, okay, we have to use the reference angle because the reference angle is always an acute angle, meaning we can use sine, cosine, and tangent to discuss the characteristics of that massive rotation angle, whatever it is. So it reads like this. The trig ratios for any angle are either the trig ratios of the reference angle or the negative of the trig ratios of the reference angle. So I'm going to show you how to deal with this. Use the following procedure. Determine if the ratio has a positive or negative sign. Determine what the reference angle is, and then combine 1 and 2 together. Okay? So they're saying, and the example they give us is to write cos of 11 pi over 8 as the cosine of an acute angle. Okay, because 11 pi over 8 is not an acute angle. I have to figure out what the basically the reference angle is there. So I figure out that the reference angle is 3 pi over 8. So I have to put a negative in front of it because of the quadrant that I end up in, and therefore I use the reference angle, 3 pi over 8, and I put a negative in front of it because I know in that quadrant cosine is negative. So what I'm going to show you is, in the next 3 examples, exactly what they did above. It'll make way more sense when you see me draw the diagrams, okay, and I do the calculations for you. So a couple things we want to be careful of here. Rewrite the same trig function of an acute angle. So I have to use the same trig ratio, right? They're saying that, the same trig function, but of an acute angle, which means an angle between 0 and 90. And when they're saying that, that means basically they want you to use the reference angle, okay? That's what they want you to use. So in question 1, again, like I said, I like diagrams so I know what I'm dealing with and where my angles lie. So cos of 7 pi over 4. So again, remember pi is like 180. So 180 divided by 4 is 45. And 45 times 7 is going to be 315, which means my angle is going to be in quadrant 4. Okay? So 315 degrees, quadrant 4. There is what your rotation angle looks like. Okay? There is 7 pi over 4. Okay, that rotation angle obviously is not going to yield a right angle triangle. So what I do is I use the reference angle, which is right in here in red. That little reference angle is going to give me the same values as if I was discussing that big rotation angle. So I create my right angle triangle right there using the reference angle. Okay, and I need to figure out what that reference angle is. So how do I do that in quadrant 4? Well, remember, you're going to go 2 pi minus the rotation angle of 7 pi over 4. So that's going to be 8 pi over 4. That's what 2 pi becomes, minus 7 pi over 4, okay, which is going to give you a value of pi over 4, which is 45 degrees. So that's your reference angle, okay? Now, you can see cosine of this rotation angle, 7 pi over 4, puts you in quadrant 4. Cosine is positive in quadrant 4. The reference angle, pi over 4, that's 45 degrees. That's up here. That's quadrant 1. So both of them are going to give you positive angles, aren't they? 7 pi over 4 for cosine is positive. Cosine of pi over 4 is also positive. So they give me the exact same value. So this just equals the cosine of pi over 4. Okay, they are the same. So this is your answer, cos of pi over 4. Okay, you got an acute angle, pi over 4. I use the same ratio, so those two calculations will give me the exact same value. Okay, the second one, I'm going to draw it out again. Okay, cotangent, which is like tangent, of negative 100 degrees. Well, negative 100 degrees is just past negative 90. Okay, so when I talk about that, there's what this rotation looks like from there to there. Da, 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 da. So where is the reference angle? Well, the reference angle is right there between the terminal arm and the x-axis. There is where your little right angle triangle and reference triangle would be. And there, like I said, is your reference angle right in that corner. Okay. So they've rotated negative 100 degrees, okay, which means in this case, my reference angle, which is right in there, is 80 degrees, isn't it? I went 90 and an extra 10, so there's 80 degrees left there. That's my reference angle. Now here's the problem, right? I am in quadrant 3. In quadrant 3, with that rotation, cotangent, which is like tangent, is positive, isn't it? So that's okay. Cotangent of negative 100 degrees is going to give me a positive value. 80 degrees, okay, as itself, just 80 degrees would be quadrant 1, right? It's between 0 and 90 degrees. Well, everything is positive in quadrant 1, so I use the same trig ratio, cotangent, of 80 degrees, and that would give me the same exact value as the cotangent of negative 100 degrees, okay? Now, the last one, 11 pi over 2. So this one's a little trickier. Okay, 11 pi over 2. Well, remember, pi over 2 is like 180 over 2, which is 90. And 90 times 11, okay, is 990 degrees. So when you see that, you're going to do 2 full rotations. So you're going to do 1 rotation, 2 rotations, and then bang, right there on the y-axis, the negative y-axis. So in that case, my reference angle, okay, is going to be right here along the x and the y-axis, which is 90 degrees. Okay, so here's the problem though. When I'm between quadrants 3 and 4, sine of 11 pi over 2 would give me a negative value because sine is only positive in 1 and 2. Okay, the reference angle there is 90 degrees. So if I had to use the same ratio, sine, and the reference angle, which is pi over 2, there's an issue because sine of 11 pi over 2, this is a negative value because I'm down in quadrants 3 and 4. Sine of pi over 2 is a positive value, so to make them the same number, I'd have to multiply that expression by a negative. So negative sine pi over 2 would give me the same value as sine of 11 pi over 2. Okay, and that's what they're asking you to do in that question. Next, determining trig ratios from a point on the terminal arm. So it says here, the point P, which is negative 15,8, lies on a terminal arm, and you can see that right there. There is point P. It's on the terminal arm, and they've even labeled R there. Mark theta on the diagram. So the actual rotation angle is going from there to there, right? That's the rotation angle because that's where the terminal arm has moved to there. But what we do to discuss that is we drop straight down, create a 90-degree angle there, okay, create a 90-degree triangle, and we're going to discuss the reference angle, okay, which is right in here. We're going to use this reference angle in here, okay, to discuss all the properties of that big rotation angle. Now, because of the point, negative 15,8, I know that the dimension of this triangle is 15, negative because you'd have to go left, and 8 units up. So it says calculate the, and again, there's that term, that exact length of OP, which is R. So to do that, we're going to use the Pythagorean theorem, which we know is a squared plus b squared is equal to c squared. But because we're on the coordinate plane now, we're just going to say x squared plus y squared is equal to r squared. Same formula, just different letters. So if I'm to figure that value out, x is negative 15, so it'll be negative 15 squared plus the y dimension, which is 8, and that will equal r squared. So when I do that, this is going to be 225 plus 64 will equal r squared. Okay. So when I go 225 plus 64, that's 289, which is r squared, and the square root of 289 should be 17. Oh, it's not. What did I do wrong here? 225 plus 64 Oh, is 289. Yeah, I did that right. Square root my answer. Okay, it is 17. I just pushed a button wrong on my calculator, sorry. So 17 is equal to r. Okay, so there we go. So now it says use x being negative 15, y equaling 8, and r, which is now 17, to determine the exact values of the primary and reciprocal ratios for that angle theta. So again, even though theta is that big obtuse rotation angle, we use the reference angle, okay, to talk about these values. So I will do the primaries first. So sine of theta is always opposite over hypotenuse, which is y over r, isn't it? So remember, sine is always y over r, okay, which in this case would be what? The 8, that's your y dimension of that triangle, and r is 17. Cosine of theta is always x over r, which would be negative and then 15 over 17. Tangent of that theta, okay, remember theta is the big rotation angle, but we're using the little reference angle to find those values. Tangent is always y over x, okay, so it will be a negative and then 8 over 15, okay. That negative can go with the 15, but it usually just floats in the middle to indicate that the ratio itself is negative, okay. But you can put it directly with the 15 if you prefer. So I'll deal with the reciprocals. So the reciprocal of sine is cosecant. So cosecant of theta would be 1 over 17 over 8, 8 over 17, which is 17 over 8. For cosine, it's secant, which would be 1 over negative 15 over 17, which will be still negative, but 17 over 15. And the reciprocal of tangent is cotangent, which would be 1 over negative 8 over 15. So that would be negative and then 15 over 8. Okay, so there are your 6 ratios, primary and reciprocal, for that specific example. All right, last page here. Using one trig ratio to determine the other trig ratios. Okay, so this question, some kids really like it because it's kind of like a puzzle, figuring out where we are based on clues they give us. The second part of it is a little trickier. It goes back to Math 20 where we have to do something called rationalizing the denominator. Okay, and again, I'll explain that more in length when we get to that point of the question. So here are the kind of the clues or the write-up of the question. It says cotangent of A is root 5 over 2 and sine of A is negative. Now when they use a capital letter like this, A and A, it's them using a letter instead of theta. So that's an angle, okay? So it's like cotangent of some angle is root 5 over 2. That's a ratio, okay? And sine of that angle is negative. Complete the following to determine the exact, okay, so no decimals, values with rational denominators, okay, for cosecant of A and secant of A. So here's the stuff that we kind of know based on what they have given me in the write-up of the question, okay? The first kind of clue, as I will say it, is cotangent of A is root 5 over 2. Now, there is no negative in front of that value, okay? Does that make sense? So the cotangent of that ratio is positive. If cotangent is positive, so is tangent. Okay, remember the primary and reciprocals follow the same characteristics in terms of being positive or negative. So if cotangent is positive, so is tangent. Where is tangent positive? Well, in quadrant 1 and quadrant 3, or 3 and 1. Okay, I said it backwards as I labeled them there. But quadrants 1 and 3 is where tangent is positive. The second piece of information says sine is negative. Okay, and sine is negative. So where is sine negative? Well, sine is negative in quadrants what? 3 and 4, isn't it? So based on those pieces of information, where do I kind of have the double check mark? Well, I have the double check mark in quadrant 3. That means that I am dealing with that angle being in quadrant 3, okay? Because of those characteristics. Cotangent was positive and sine was negative. That puts you in quadrant 3. And that's kind of where they lead us in part A. It says, since the cotangent is positive and sine is negative, angle A must be in quadrant 3. Okay, so that's just what I showed you off to the side there. Now, since cotangent of A is root 5 over 2, we know that that is going to be x over y. Okay, why do we know that? Because we know that tangent is always y over x, okay? And since we're dealing with cotangent, Okay, it's 1 over that, so that means that that's the x dimension and that's the y dimension, and therefore I know what that triangle looks like that I can draw in quadrant 3. So this is what results from that. Okay, I know that I'm in quadrant 3. Okay, so I would have some kind of rotation angle, okay, that has ended up in quadrant 3. So it would look something like this, right? Quadrant 3. So there's your rotation angle. Now, I can't really deal with that rotation angle. I have to talk about the reference angle, which is between the terminal arm and the x-axis. So I draw myself a nice little right angle triangle. Okay, here is the point, okay, where it's on the terminal arm. Okay, again, this is the reference angle in here. So the x is root 5, and the y is 2. But again, they both have to be negative, because if I'm starting at the origin, I go root 5, that's to the left, that's negative, and then I go down 2, so that has a value of negative 2. There's the r. Okay, we don't know what that value is yet. So it says sketch a diagram and draw the reference triangle illustrating the information above, and that's exactly what we have done there. Now in part C, it says use x squared plus y squared equals r squared, so your Pythagorean theorem, to determine the value of r, and then determine the exact values of cosecant of a and secant of a. So in order to find cosecant and secant, I need to know what r is. So again, just set up your formula. Okay, so x squared plus y squared will equal r squared. The x value here is negative root 5. I have to square that. The y value is negative 2. I have to square that. Okay, and I'm looking to determine r. So negative root 5 squared is negative times negative, which is positive. Root 5 times root 5 is just 5. So it'd be 5 plus negative 2 squared is 4. So this will give you 9. That is equal to r squared. So therefore 3 is equal to r. Remember, when I take the square root of a number, I do have a positive and a negative value. But because we have already determined that r is always positive, okay, r will equal 3. So from there now, what I do is I go and I calculate, okay, first cosecant of a. So remember, cosecant of a is the reciprocal of sine. Sine is y over r, so this is going to be r over y. So this will be 3 all over the y value, which is 2, and it's negative. So negative 3 over 2 is your value for cosecant of a. When I go and do secant of a, okay, you're going to see this. Okay, this is the tougher one here. So secant of a is going to be r over x, because it is reciprocal of cosine, which is x over r. So when I do this, the r value we said was 3, okay, and then this is negative, and then root 5. So a lot of people at this point would be like, oh, I'm done. But here's the issue, right? That value in the denominator is what we call irrational. So we have to rationalize the denominator. So going back to math 20, what we do is we multiply, hopefully you remember this, both the numerator and the denominator by that irrational value, which is root 5. Because in essence, I'm just multiplying by the number 1. Anything divided by itself is 1. So you're not changing the value of your expression, you're just changing the way it looks. So now in the numerator, when I go 3 times root 5, that's 3 root 5, and it's still negative. And in the denominator, root 5 times root 5 is just 5. So there is your expression for secant of a, negative 3 root 5 over 5. And the question you'll ask is, do I have to rationalize the denominators? And the answer is yes, you do. Okay, we do not leave ratios with an irrational denominator. And what are the irrational values? Well, root 3, root 5, root 7, root 11, root 13. You get used to seeing them over and over and over again. Okay, so when you see those values, we rationalize them by multiplying both the numerator and denominator by that irrational value, and it will rationalize the denominator. And we're okay if we have an irrational value in the denominator or a numerator. We just do not want it in the denominator. Okay, so practice those skills over the next day or so. I'll be back with another lesson very shortly. Hope your test went well. If you wrote it today, if you're writing it tomorrow, good luck. And